Hallo? 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 Ja, warte, warte, warte. Ähm, hallo? 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 Test, Test, Test.
gar nichts. Pleasure to be here. I was asked to say a few words because I'm the mayor who is responsible for mobility in the city, but also, as has already been said, as a TUM alumnus, unfortunately, I never made it to the TUfast Eco Team, which I'm really sad about this now, especially since I see all sorry. As a mayor, you don't speak English too often, so I'm looking for the right words. There's all the successes, now I got it. So, I'm a big fan of your work, and I want to say you why I am so. First of all, you're showing which progress is possible with all the new technologies we are researching at our universities, and we already heard a few numbers. I'm super curious what we will hear later in the evening. Second, and I think this is very important to say, especially as someone from the politics, you show that this progress is possible because people from different type of research fields, but also from different countries work together. And I'm so happy that this is possible in our town, and yeah, that we can see what is possible if so many people come together from all around the world. And third, as the mayor who is responsible for mobility in this town, I can say there's a big culture war about mobility. And there are car enthusiasts on the one side, and there are people who are for renewable energies, for example, on the other side. And you show what is possible if both sides come together, and I think this is exactly what we need as a society right now. So thank you so much for all of your efforts. And I'm super curious to see the new car now, and most of all, good luck for Australia in the coming year. Thank you.
Thank you, Dominic Krause, for the fantastic speech and the insight into what many of us maybe don't see on the everyday basis, the inner workings of such a project and the impact it has on our wider society. Now, I have a few questions that I want to intrigue you with here tonight as to what the complexity of this project might mean. Where do you start? Where do you begin a journey? And how do you lay down the foundations to a project so big and so complex? As head of operations, a role in Hofa last year, that was my job. To upkeep the material and financial stability of this project and to ensure and enable my colleagues to do their best work, knowing that their vision can be turned into a reality. As I look out into the audience tonight, I see men and women of business, and I can definitely say that we all understand that the material logistic complexity of this project is something that is incredibly high. The slide, please. I have a very nice slide of like a diagram of the car. You'll see, just give it 1 second. Okay. For lux025, over 35 different partners from 25 different countries and across 4 different continents came together to make this car a reality. Here on this slide, you can see an exploded diagram of the car, not revealing too much, and just some of our major partners who helped us create this into a reality. The thing is, these companies, they come from such a wide variety of industries. We have electronics, robotics, engineering, energy and sustainability. And to me personally, as head of operations, this car is a symbol of international cooperation. It is showing what can be possible when companies come to us with a joint venture to create something that perhaps they haven't explored. Even though it is a prototype solar vehicle, it shows the demands that the future will have on us, not only the engineers, but the supply chains, the materials, and the technologies that will be needed, maybe not in the future, but right now, as we head towards the sustainable mobility revolution. This is something that lux025, in my opinion, aims to highlight and lead. Another significant challenge, which we quickly realized has to be solved, is the production of such a difficult car. We had to teach people how to handle these materials. The necessary experience had to be passed down from previous seasons. And for over 24 months, as mentioned before, this car has been either in the design or the production phase, ongoing 24/7 production. At the end of the day, I must wholeheartedly thank everyone here tonight, as well as the people who were unable to attend, as without your contributions and very generous support and dedication to our project, none of us would be here tonight. I must especially thank our partners and Audi for giving us the backing that this project needed, which we couldn't provide ourselves. And obviously, our monetary sponsors, because in the business world, we all know the saying that time is money, and some resources are quite difficult to acquire because of the technologies we work with. They might either be in low quantity of production or just unattainable. We must thank them very sincerely for giving us that extra step in acquiring the final touches we needed to finish this project. Thank you.
Thank you, Benjamin. And just like he said, the monetary sponsors and material sponsors were what funded our project, were what made this possible. And so now, as you might know from about everything here on the little flyers that you have on the table, on your name tags, on our shirts, one of our main sponsors, well, our main sponsors, which we are very thankful for, is Audi, and we have some special guests, again, here tonight from them, so I would welcome to the stage our speakers from Audi. Thank you so much.
All right, good evening, everybody. My name is Christian. I'm part of the Audi employer branding team and head of the Audi Universal Sponsoring. Well, the location, too close to the speaker maybe. The location is incredible, thanks to Pshore for having us here. And the team is maximum incredible. Give yourself a big round of applause. This has been outstanding, and when I'm talking about this, it's like, okay, since when do we have this relationship with Tomo, with TUfast? It's nearly 2 decades that Audi has been into sponsorships with TUfast. It's nearly 14 years I'm with Audi, and about 5 years that I have the honor to be responsible for the sponsoring and to know many of you and to be very happy to welcome many of you already at Audi at the headquarters in Ingolstadt. And we've been pretty much focused on the TUfast racing team during the last years. And then we've been talking, like Tim came up, Kati came up, like we want to build a car that's taking part in a race in Australia, that's doing solar races, 3,000 kilometers. And I was like, wow, what's that? And yeah, we got into closer contact, and then of course the idea was born to become one of the main sponsors for that. Before we go on with this presentation, I really want to thank you guys personally for your dedication to this project. I've been on Sunday, 2 days ago, Sunday at like 8 p.m. I just handed over those lanyards. Maybe I was a little late this time. But anyways, I've been to the garage. 8:30 Sunday, 30 people working there, and everybody was really, like, I'd say kind of maybe not too relaxed and some kind of, well, but I was sure you guys will make it, and I was here like at 5:15 today, and they made it. So please give yourself a big round of applause. So when it comes to the team, when it comes to the cooperation between Audi and TUfast, one thing is the sponsoring thing, and the other one is, of course, how to connect it to Audi, and what's the idea behind it. And when we are talking about current trends in automotive, it's a lot about autonomous driving. And this is why I brought Jan with me on stage. And Jan, you are a part of the Audi team in the autonomous driving. So just let us know, give us a little insight what's happening there.
Of course. Does it work? Oh, now it does. Thanks, Christian. So exactly, maybe a few words. It's essentially thanks to Christian that I'm at Audi now. Not too long ago, I was actually essentially where you are at university, and Christian and I met on a Facebook career fair, and he said, look, what do you think of the chance of developing autonomous driving at Audi in a big team with lots of funding? And now I'm here, so thanks Christian again for that. And the bridge to that now is when I look into your faces here, I essentially see the same excitement and the same hunger to actually push the technological envelope a little bit further as we have it in our team, so that we can finally have an Audi drive autonomously on its own over the highway. So this is really exciting to be here.
So when it comes to the Australian challenge, really driving 3,000 kilometers with this insane long car behind me, we can maybe have a sneak preview. I think from my perspective or from my point of view, it's really important to have the right strategy, to have like the data strategy. What do you think about this?
I think this is exactly the important point, right? If you look at the technology nowadays, right, for example, with the recent advent of large language models, of vision language models, it's hard to imagine what is it that we can't compute, what can we not automate. And of course, let's say developing an autonomous driving stack is, as of now, it's much, much simpler than it was, let's say, 10, 20 years ago. And of course, didn't stop anyone from claiming that 10 years ago, just wait a year, it will be done, but we're still not quite there. The reason for that? The reason is essentially that it's not just about developing some algorithms that perform well, but actually proving that this is actually safe. And how do you prove that an autonomous driving system is safe, especially given that you want to have millions of customers that will drive it every year, every day, let's say back to work and back again for hundreds of kilometers, right? That's an insane amount of driving time. If you will just encounter the smallest weird situation that you didn't account for beforehand, then you will probably have an accident on your hands. And we do have our autonomous driving stack, and I've done some test drives with it. It feels actually pretty amazing. However, it's essentially a data challenge. You need to collect enough data to actually ensure and prove that the system is safe, and it's actually safer than a human driver. And we essentially do that by using our test fleet, collecting a whole lot of data sets from our sensors, terabytes of data, and just really proving, okay, the stack is behaving correctly in the right situations. And from what I've seen here with your challenge, optimizing the driving strategy for your system is essentially a data-driven challenge there as well. So I'm super excited to see how you will fare, and let's see what we at Audi can then also learn from you guys, how you tackle your respective challenges.
I think that's exactly the thing. What can we learn from you? And there's many things, either on technical side, but also with this passion you're handling this project. I've just been talking to Tim, the guy just standing up here. The smaller the eyes get, the less, of course, they had sleep. I'm doing this Formula student and stuff for a couple of years. People usually told me it's better to work 60 hours and then sleep 12, and then you can work another 60 hours. That's like how this works, and it's really amazing, and you see the result. Before we end this presentation, a couple of weeks we took pictures with wider eyes with some of the representatives of the team or some team members, and I hope the slide is ready. that we can show you. Yesterday, on the Audi.com homepage, the new site or the new page basically went live. And if we can scroll down or maybe have another one, however, this is the only one. Okay. We have interviews with Malu, with Kati, Tim. I think it was 3 or 4 people. Just have a look at the audi.com/career site, and we really love it, and it went live yesterday, so perfectly timed for your rollout. That's it from our side. We wish you all the very best for Australia. It's gonna be a team challenge. It's not gonna be a technical challenge, but it's gonna be a team challenge. You're gonna hang around this for 6 weeks. We are looking forward to receiving updates daily on social media or on our WhatsApp accounts, wherever you want to reach us. Thank you for having us, and we're looking forward to see this one live now. Thank you.
Ja, herzlich willkommen. Hello to everybody. My name is Jürgen Lochbihler and I'm responsible here for this restaurant, Der Pschorr, in Munich. In January, 2 students from the TU in Munich had an appointment with me for fundraising. I did not know what they want from me, but at the same time there was an article in the Münchner Merkur that the TU München is again one of the 5 excellence universities in Germany. And as we, as team of Pschorr, are the opinion we are an excellence restaurant, we had the opinion I'm of the opinion that matches. So we are not from engineering, we are from hospitality. And after talking about, let's say, 1 hour, Tim, 1 hour, we fixed 4 major points. We will give you the space and the food for this rollout today, just from the Pschorr, for you tonight. Then also, we want to be at the clubhouse of the Verein TUfast, and they have an annually a meeting, Jahreshauptversammlung, and we have upstairs here the Resi, and we will make you an annual meeting upstairs in Resi in October. And as Tim told me, there are about 40 people with the race. I said, they need some food or something like this, or catering. And then we decided to make the catering for the racing team in Australia. And last but not least, we have down in the Keller the Alice, and there we have the possibility to live broadcast not only the start of the race, so during the whole race, to have a live broadcast down in the Keller, in the center of town of Munich, and see the pictures from the other side of the world live. So after 1 year, we will see if we are really excellent, but I trust in my team, and I make only decisions. My whole team, about 100 people are working here for Pschorr. I thank you to my whole team. They go with me these big steps. Thank you so much, and enjoy, and really, I wish you good luck. Not only good luck, you should be the winner. Thank you so much. Thank you.
we're so grateful for everything that we're getting, and me personally, I am so excited for the food in Australia. If it's as good as it is here tonight, I cannot wait. And in the spirit of that, we're gonna take a break now. Food will be served right now, and we'll see you back here in about 40 minutes. Thank you.
It has been a lot of trial and error. It has been a lot of work. I've been figuring this out with me. So make some noise for them, please. Yeah. So now to the part that Malou already announced I would be doing. Well, what's the race that we've been preparing this car for 2 years for now? So let's talk about the Bridgestone World Solar Challenge. The concept sounds quite simple. There's a bunch of student teams, they build their own solar car, and then they race from Darwin to Adelaide. Small fact, it's 3,000 kilometers, so it's not that easy anymore. And there's a bunch of challenges on the way, some of which I will highlight in a bit. But if you've been following the team for a while, you might know the Shell Eco Marathon and the circuits that are actually pretty small and quite different to 3,000 kilometers. However, the Bridgestone World Solar Challenge starts not too different with something that every good race should have, and that's qualifying. On the 23rd of August, we have one lap around the Hidden Valley Raceway that you can see actually, oh, no you can't, well never mind. The Hidden Valley Raceway in Darwin, and that will determine our starting position for the next day when the real race can start. So then, on the 24th, we get ready to start the real race and leave civilization behind for the next few days. And I've always struggled a little bit to fathom just how remote can it actually be in the Australian outback. So I brought a little fun fact. I looked up how many cities above 10,000 inhabitants there are on our whole way, the 3,000 kilometers. And you can have a guess. In total, it is 3. One of them is a suburb of Darwin, so it's like 50 kilometers down the road. The next one is Alice Springs, that's 1,300 kilometers down the road. And the next one is actually already on the south coast of Australia, which is Port Augusta. So, as you might recognize, there's not too much on the racetrack that we're racing on. So, what is it actually like to race there? I can't fully tell you, I haven't been there yet. You can watch it live in about 3 months. However, I've watched a lot of the vlogs of other teams like Sonnenwagen, Top Dutch, and Optus, whoever. It looks really fun, it looks really stressful, but also really, really exciting, and I'm really looking forward to the race. And we will be spending most of the day driving down a straight road, because that is just how the roads are in Australia. However, there will be some control stops from time to time. Now you might ask, what's a control stop? It's basically just a short stop where we change the driver, because once the driver has been driving in this car in the Australian heat for maybe 3 hours, they are very exhausted, I can promise you that. It is not that comfortable because it's a race car, obviously. And so we switch drivers, we get a chance to refill, and they also actually check our car. And then after exactly 30 minutes, it's back on the road. And that continues until 5 p.m., which is the end of the race day. Now, since it is quite far to Adelaide on the first, second, third, or maybe even fourth day, we won't be in Adelaide. Instead, we're in the middle of nowhere. So what do? Well, we set up camp, and sure, we'll prepare our food for the night. We have to set up our tents, we have to check up on looks, because obviously the roads in Australia, if it's that remote, are not that good. Sometimes there's bumps, sometimes there's animals on the road, so we have to check that looks is still fine after the race day. And we have to do all that within under an hour, because then it gets dark. Now, that was like a really short overview of how one day could look. Then the next day, we get up bright and early, and we continue our journey towards Adelaide to then hopefully arrive first and win the trophy on our first time participating. Now you might ask, what's the best strategy to do that? Well, I'm definitely not the right person to ask that. However, I do know someone who is. So make some noise and a big round of applause for Marius.
Hello, my name is Marius. I'm head of driving strategy. So this season, we decided to create the new sub-team, which is called the driving strategy sub-team. And I want to tell you the small story, how it created. So basically, in at the Shell Eco Marathon 2022 and 2023, we already gathered some experience with driving strategy. We did some evaluations on the used energy during the track, and we realized that when we optimize this, the way we are driving, we can really significantly impact our performance during the race. So, what is driving strategy? Driving strategy is asking the fundamental question of how we are using the energy, the limited energy that we have during the race. With energy, I mean the energy is coming basically from two sources. First of all, from the battery, which is just 3 kilowatt hours, and the rest is from 6 square meters of solar cells. Just, I want to emphasize that 3 kilowatt hours of energy is really, really less, and that makes it so important that we have a driving strategy subteam that can analyze where we're using this amount of energy. So, basically, we and the driving strategy subteam, we have a constrained nonlinear optimization problem. The difficulty could not be more hard. Basically, we have 3,000 kilometers, 5 days, and over 200,000 parameters that we are going to optimize. This kind of difficulty is normally not solvable by most optimizers. Most optimizers are just too slow. They are not able to solve that in any kind of way. So we could have just backed down on it and used a very, very rough estimate, which most probably wouldn't be of any use for us. But we didn't do so. So we decided to take AI technologies and powerful hardware to create such a simulation which is very powerful. We can simulate with 1 second resolution. We use real-time data, and we can at the same time simulate different kind of scenarios, like different kind of weather outcomes, different kind of weather predictions. At the same time, we can also, and we will, actually integrate live data from it. So while we're doing the race, we will integrate the live data and even better forecasts into our model to create even better predictions. To do this, we have a lot of telemetry data. We have the data from our car, we have the data from our weather car, and we feed all this data via satellite to our servers in Munich. And at the same time, the results which were simulated in Munich are going back to Australia, and there we have our driving strategy subteam to analyze the data and decide what is going to be the right strategy for our team. So, actually, we also have some people in our support vehicle from driving strategy. What are they doing? Basically, they are monitoring all the parameters during the race, like temperature of the wheels, temperature of the motor, the amount of energy that's going in, and from that on, they can adapt to any kind of situation that could happen during the race. They will adapt our strategy, create new simulations, and decide what is the best for our race. So, with all that, I want to really thank my team who did great efforts and worked tirelessly on building the car, on building the simulation, which surpassed my expectations. Let's make the best out of the race.
Introduce one of our next guest speakers. It is a professor from a very technical university of Munich. I would like to ask to the stage Professor Dr. Markus Lienkamp.
Yeah, good evening to everybody, and thanks a lot for the invitation. I'm very proud to be here. I'm very proud of you, of all the students from this big team. And I'm really very happy that we can have that celebration here in my favorite restaurant, actually from Munich. It's a Pro. To be honest, we had a briefing, and my biggest problem and our biggest discussion was what's the language I should use. And the team was saying, our team language is English. But to be honest, I'm not a native speaker, and I didn't want to annoy the Americans or British native speakers here. Who's native speaker? English? Oh, 1, 2, 3. Okay. Then I thought maybe I should speak Bavarian, because we are here in the Pschorr. But to be honest, I'm Prussian, and since 16 years I'm now in Bavaria, but I still don't speak Bavarian. Then I thought maybe some people are here from Portugal or Brazil. Yeah. So podemos falar português? Ótimo. Yeah, and I thought, okay, there are maybe 2 little people from Portugal. I want just to give the international students one recommendation. I was in the US for a year for studying, and I was so lazy at school, I couldn't speak English at all. And I did my master's in the US, and I had to learn English. I was then later on in Portugal, and I'm not really good in languages, and I learned Portuguese, and still today I speak Portuguese. And just my recommendation, the takeaway for today for the international students, try to learn German. And there's an obvious reason. You can delve much better into the German Munich culture, but there's a much more important reason. I've talked to an engineering service provider a couple of months ago, and he was saying, I'm selling my service to German OEMs. And I can sell a German engineer for 65 euros an hour. And the OEMs don't pay for that. They pay maybe 30, 40 euros per hour. And the only chance to make that is to offer, let's say, a mixed price. So they take 5 people from abroad, a lot of people from India. They work for 20 euros per hour, and they take 1 German-speaking engineer for 65 euros per hour. So you triple your salary if you learn German. Okay, but now to the Eco Team. What is our main product from TU Munich? Our main product, in my opinion, is education. And what can you learn at TU Munich? You can go to our lectures. Sometimes they are boring, you have to learn a lot, and so on. But you learn much more if you join such a team. We have here a team of, I think, about 100 students from different faculties, different disciplines. You learn from each other. You learn how they think, just other cultures. You learn about other views, about other countries. It's a lot of learning when you see how the others behave and work. So that's one part of the learning. And I want maybe talk to the parents of you. Some parents are here, or? Yeah. You might think your kids are wasting time. So they might ask you to finance you for another semester because they've lost a semester in that team. It's not a lose, it's a win, definitely. They learn so much more. In our lectures, they're just learning to reproduce. In this team, they learn to produce. And it's a total different world if you just have to reproduce what we tell our students in the lectures, or if you want really to tackle a new problem. It's a greenfield approach, something nobody has done before. And that's where you really learn. And today we just had a discussion in some meeting from professors, and a colleague of mine was saying the big difference between people from TUM and people from other universities is that the TUM students are very self-driven. They are like not just reproducing, they are really active. They take the lead, and I think that's the important part you learn in that team. Secondly, I want to thank all the sponsors. This project is not possible without you. You know, TUM is a very poor university. We cannot afford financing such a project, at least not the chairs. Maybe you ask the officials at TU Munich. And I think it's really worth supporting that. We are doing that at our chair by providing service from our workshop. So whenever you come and you have some problem, ask our workshop personnel, and they are always happy to help you. Yeah, I want also to welcome the other teams. Today I've heard there's the TUfast team, TUracing team, autonomous team, Motor Electric, and top Dutch solar team. I'm not sure what they are doing, if they are racing with caravans or other means, but so welcome to everybody. What you can learn from the other teams is, and that's what a lot of PhD students are telling me if they are going abroad. At home, it's best. TUM is best. So you learn how good we are at TUM and how good the boundary conditions are. So thanks a lot to everybody. I wish you all the best for your race in Australia, and I wish you a nice and good evening. Thank you.
Danke. Thank you, Professor Dienkamp. That was very well said. Now, to go back to our project, let's talk about how this project came to life over the last 2 years. And for that, I want to ask to the stage very own technical director, Tim Butkus.
All right, thank you for bringing me to the stage, Malu. So, how did we start the season? When did we even start? So we kicked it off in March 2023. So basically more than 2 years ago. It's quite a long time. It's quite a long time, and it can stretch and stretch and stretch. So what did we do? We obviously had different projects before. So our focus got shifted, and with the shifted focus, we had to redo many things. We had to get a new structure. A different structure because the project is so much more long than the ones before. So we had different ideas. And how did we start? The main focus of such a huge car, because, I mean, you clearly can see it's quite long. Maybe it's a bicycle beneath, we don't know. I mean, come on, you cannot see it. So, yeah, we started with the aerodynamics. The aerodynamics, we kind of knew how the car is going to look like, or, like in the shape, like the sizes, the solar arrays. So we started with that, and also the black boxes. So we called that the version 0. The version 0 is basically just a huge box. A huge box doesn't look like a car. Maybe inside, not even, like, it's even worse, we just have blocks. Maybe it's the packaging. For some of you, like the packaging, we have each of every running gear part has its own packaging. For example, you can think about your wheels, we just have a block. And that's kind of how we started. So version 0 is not a real car, and it's basically just dimensions.
That sounds like a very seriously long process. How did you keep track of all of it?
So we treated every version as a huge milestone. meaning we had many versions. In total, we had roughly 8 versions till we came to an actual CAD freeze. The versions themselves, we had to revise them. So after version 0, obviously we looked at the car, we had the kind of an idea of the COG, we kind of had an idea how heavy it could be, we had an idea how kind of where things should be, and then we started. Like version 1, like everything was very rough. And so on and so on. Over all the versions, we iterated. The car got more lightweight, more aerodynamic, more efficient, and so on.
Well, you mentioned deadlines in the CAD freeze. I remember that being like a really hot topic. Like last year, there was a lot of discussion about that. What about it? Can you tell me more?
Yeah, sure. So the CAD freeze is basically the freeze of the whole season. It means everything that we built on engineered and designed is done. We will move afterwards to production. It doesn't mean that we completely stop engineering at this point, because it will continue. So there is kind of an overlap. In theory, this project is done in CAD. Slight parts still can be done better. This overlap is... we use CATIA. So we had many versions, and in the end, the last version should be the best. And this CAD freeze basically just froze it in time, and some small overlaps were created because some parts are produced later on. So we had some bit more time to make him even better. Because, I mean, we have crazy engineers here. We all know that, and they want to do more. They want to do it better, and they want to do it more lightweight, and so on. So if they have a great idea, and if they want to continue, obviously we cannot say no to that. And, I mean, it's kind of free labor, so.
And now, here we are, about to see the result of all that crazy engineering that you said.
Yeah, so Lux is not only the outcome of those designs. It's not only the outcome of the calculations we did. It's majorly about what we did together. I mean, all of you can, you know what we did the last weeks, basically. We stood there late nights. We stood over the whole season, many weekends. We spent overnight shifts. You spent hundreds of hours building this car. So this project is not about only the calculation, only the CAD. It's about the team building that comes within. It's about the actual experience that we gathered together. So I need to say a huge thank you, because without such a team, this project is not a project.
Yeah, Tim, I genuinely think you said it all. It was such a huge teamwork. And I think we're here. I think it's time for the highlight of the evening. I want to ask Catherine Somerville to the stage, our team manager. You guys have led this project since the very start, and it's only fair that you two should do the honors of revealing Lux. So, without further ado, let's reveal Lux025.
Wait, challenge in a short way, in a single sentence. Let me think. Kangaroos.
This is something the team is going to look back at for the rest of their lives.
We are definitely innovating. We are pushing the boundaries of lightweight design. If you see our car, it looks so heavy, but every time we tell somebody our weight, they don't believe us.
There's no limit to your creativity or your imagination. There's simply a set of problems, and as an engineer, you have the artistic freedom to create the perfect solution to this unique problem.
I'm very excited to see the car driving on the road in Australia. I'm really glad that we have the opportunity to do that.
It's all just one huge team effort to get to where we are today.
round of applause for lux025. So this is it. This is what we have been working on over the last 2 years. But seeing all this, it asks the question, does this actually work? How does this actually work? How did we do this? And yeah, there's so much more to this car than what you can actually see right now. And it is actually your lucky day, because we have some technical team leads here today who would be very pleased to answer all of those questions, to tell you how this car works. So basically, we're going to work our way from the outside to the inside in this next part. We're going to start talking about the outer shell, which is what you can see right behind me at this moment. And then we're going to go inside, talk about the running gear of this car, and then finally talk about the electrical systems. So now I want to ask to the stage our head of vehicle body, Leon Federschmidt.
Yeah, so hi everyone. I'm very excited to tell you about what we've done on the chassis and vehicle body this year, and how we basically took upon us one of the most ambitious builds we've ever achieved as a team. As has been mentioned before, we started the development of Lux with the previous regulations, which gave us a solid foundation to build on. However, once the new rules came out for this year's competition, so for 2020-2025, we had to make several changes. Those changes especially affected the monocoque and outer shape. The most noticeable change in the regulations there was the wheelbase, which was increased significantly, and the solar array, which was also increased significantly to 6 square meters. At the beginning of the development stood the optimization of the aerodynamics of the car, while at the same time we tried to consider the packaging that was given by the regulations and running gear. From the very first version of the outer shell, with a CDA of 0.11, we went through insanely many iterations to reach the final CDA of 0.09, which is incredible for such a car. To get to this, we used our optimization algorithm and continuously improved on our aerodynamics, with an adjoint optimization of the aerodynamics of not just the whole car, but also very specific parts, like for example, the canopy. We were able to optimize the aerodynamics even more. This optimization tells us, for example, which areas of the car need to be adjusted in order to improve aerodynamics, and gives us a nudge for CAD, and basically laid the groundwork for the actual design of the outer shell. Of course, we were only able to achieve these results while at the same time considering the constraints given by the solar array. We had to somehow integrate 6 square meters of solar panels into the top shell of the vehicle. With a highly complex simulation that reflects and predicts every 5 minutes of the race, fed with data from solar irradiance, temperature, and map data, we were then able to determine the perfect geometry of the outer shape with as little shadowing as possible on the solar cells. For this, we created a model of the sun, and the shading on the cells was simulated at different times of the day. And this data was then used to develop an optimal module layout and cabling. However, obviously, every small change to the array layout had to be adjusted in the design of the top shell, which meant several iterations until the final version that you can see now here and in the actual car. This version perfects our goal of minimizing the weight of the car while at the same time maximizing our solar power. Another one of the key challenges this year came from the crash regulations. While they weren't completely new, they were a lot stricter than in the previous seasons, especially when it came to subjects such as energy absorption and wall thickness. This basically pushed us to change our structural concept. For the first time in our TUfast Eco Team history, we used 20mm and 30mm honeycomb. This allowed us to pass the more strict safety regulations very easily, while still giving us the flexibility to optimize different areas of the monocoque. However, obviously, those cores come at a very high cost, and that cost is weight. So those cores made the monocoque a lot heavier, especially in the early design stages. Our first prototype, the first version that we designed, weighed in at over 75 kilograms, which obviously we knew we had to improve. So we started a full layer optimization of the monocoque. We broke the monocoque down into several different layers, analyzed local load paths, and tailored each section of the layup to carry only as much material as needed. This resulted in an obviously insanely complex layup. However, we were able to maximize stiffness and minimize load peaks. In the end, this level of optimization did pay off though. The monocoque, as you can see it now in our car, we were able to bring down the weight to just 47 kilos, which is a 30 kilo improvement over the first version, while still meeting meeting the same stiffness and crash performances we were expecting. Also, for the first time in TUfast Eco history, we implemented a roll cage, as you can also see. This roll cage serves to protect the driver's head in case of an overroll. And even here, with the optimization of material and geometry, we managed to bring down the weight from initially 13 kilos to just 7 kilos. But the monocoque was obviously only part of the challenge in such a big car. We also redesigned all appendage parts, the front of the car, the rear of the car, and the top shell of the car. Every one of these components had to be rethought to minimize the weight and obviously to match the outer shape and solar array. For this, we switched to lighter prepregs, and in many areas we replaced the standard core material from aluminum honeycomb to Nomex, which is an aramid paper honeycomb, which cut down the whole weight of the chassis to just 80 kilos, including the monocoque. Since we're speaking of size already, the whole car is 5 meters 80 long. That is the maximum that we are allowed to have from the regulations. This is a challenge to produce, to manufacture, obviously, and for the first time, basically, also in TUfast history, we had to split up our monocoque in two separate halves. That means we first cured the outer layers of the lower half of the monocoque and the upper half of the monocoque, and then bonded them together afterwards. Also, for the outer shell, we had huge challenges in alignment, joining, and finishing of the whole car, as none of these parts that you can see here were able to be produced in just one mold. For example, the top shell and the underbody each had to be split up in minimum 4 individual molds. However, I think, as you can see, the process in the end turned out pretty nice. You can barely see any joining issues, so I think we can be very, very proud of our chassis. Throughout the build phase, we, in total, as a team, spent thousands of hours in the workshop, basically doing everything from mold preparation to layup to bonding to finishing to sanding ourselves, and only with huge effort from every single one of the every single team member, we were able to achieve this perfectly. Beyond that, our chassis is something that we are really proud of. Every part of it reflects the time, the effort and passion that every single member of the team put into it. Thank you.
Thank you. So my name's Luca, and I'm head of running gear, as you can tell by my running up the stairs. And I'll take you on a small journey of the engineering challenges that we faced as a mechanical team while designing lux025. Bridgestone challenge for the running gear team is it's a big question that is posed to a new generation of engineers that needs to be answered. First off, of course, what is mobility? And how do we implement it in a way that is sustainable, in a way that a person can use the least amount of energy to travel a long distance? And from an engineering perspective, we tend to find as many problems as we can and then solve them way over the top. And that's exactly what we did, because we're good at that. The first problem is what we saw from analyzing previous races: stability in side winds. It's a problem that all cars struggle with at the Bridgestone, and it stems from the fact that the rules say you need to have 3 wheels. And from an efficiency standpoint, that's excellent, because 3 wheels have less resistance than 4. However, from a stability standpoint, that's absolutely terrible. But we compromised and we used 3 wheels. We used a tadpole design, which means we have 2 wheels in the front and 1 wheel in the back. We then, early on in the development, put a lot of emphasis on this side wind stability. We ran a lot of analysis on it. We wrote a thesis about it. We did a lot of multi-body simulations in order to assess how small can we get the wheels together, so the track width, without, how wide can we get it without annoying the aerodynamics team too much. And we compromised by putting them really, really close together, but just close enough to keep us safe. Now, the second major challenge, of course, that you have as a mechanical engineer when designing something as efficient as this is weight, and the trade-off between reliability and having a design that will work under all conditions and having an extremely lightweight vehicle. And analytically, for every 1 kilogram that we save, our average speed will increase by 0.18 kilometers per hour. So with all the changes that Leon's already done to the chassis, we're able to suddenly drive 5 kilometers per hour faster, just off the bat, compared to not optimizing or not considering anything. The way that we were able to implement the weight savings was a method called topology optimization, which is basically the computer giving the optimal solution and removing as much material from a structure as possible. In the past, topology optimization yields extremely organic structures, such as the front upright on the left. This is a raw interpretation of that topology optimization, in contrast to the part on the right, which is the lower wishbone, which also stems from topology optimization, but it uses a manufacturing constraint, which does increase the complexity of the simulation and optimization considerably, but it means that the part is conventionally manufacturable while reducing the weight to about 30% of its original design. The next major challenge for running gear is the optimization of mechanical losses. That's our job. We want to create an extremely efficient drivetrain that allows the car to coast without losing any energy. And we did this by addressing the 3 major causes of friction in, well, any vehicle, at least mechanically, other than aerodynamics. and that is the tire. The tire is a custom Bridgestone that they optimize every single season at the Bridgestone World Solar competition, and that we use there to test it and yield very, very good results. The next point of friction are the bearings and the drivetrain. We are using super precision bearings, and I'm not using that as an exaggeration or an adjective. They are literally called super precision bearings. Because they use ceramic, they are extremely precise, extremely low friction, and of course, very, very low, very, very high efficiency. Lastly but not least, of course, are the brakes. The brakes, of course, cause the most friction. They're supposed to. But they shouldn't always cause that, which is why we have an optimized brake disc that has low rotational inertia, does just what it needs to do. And while driving on the long, relatively even stretches that we have, the brake calipers are disengaged as much as possible without sacrificing safety. Talking of which, safety is the top priority of running gear, and we address this in quite a number of ways, from assuming our load cases, the car will survive a lot, but also having active safety measures, which so far the TUfast Eco Team has not yet implemented in any of its vehicles. lux025 has a collapsible steering shaft, and while that's conventional, or compulsory I should say, for all conventional cars, we used a very new approach by having a custom carbon fiber wrapped shaft that will collapse under load. It only works on torsion, but as soon as you compress it in the event of a crash, either by the driver or by an external vehicle, it fails. Truly, as the head of running gear, I am very, very proud to present the very best running gear that the Eco Team has ever put up, and I'm very proud of my team for pulling it off and the late hours that we've done assembling it. So thank you very much. One round of applause, please, for the running gear team. I'd also like to give a nod of appreciation, first off, to all of the other teams that have participated in the Bridgestone World Solar Challenge. We learned a lot. We've never done this before, but we scrutinized the designs, we chose the very, very best of the best, and we think we made it better. But we'll see. I'd also like to give a nod of appreciation to the racing team who helped us and who inspired us to create some very, very good designs from theirs. And the motor team, who also supported us very much during the designing phase. So thank you to the entire TUfast family. I am completely confident that the running gear will do excellently in the Outback. And now I'd like to hand off to the team that puts the power in solar power, the electrical team by Shurya and Janish. Thank you.
Thank you very much, Luca. Good evening, everyone. I'm Janish, and
I'm Shaurya.
And we are immensely grateful that we had the privilege of leading the electrical team, really amazing team, for the Bridgestone World Solar Challenge this year. And now we were given a challenge. That was to have the car driving in solar power across the Outback for 3,000 kilometers. That means we need to have some kind of buffer. Now, to conquer this challenge of this magnitude, we need a solid foundation. And for our solar car, one of the many foundations, that is the energy storage pack. That was since we were competing for the first time, everyone would think, okay, let's buy off-the-shelf batteries, put everything together, and we run the car. But no, that's the challenge in that, and we like challenges. And therefore, we decided to design our own battery pack and assemble it by us. And therefore, there was not just the cells that we just took it off the shelf, but also like the mechanical design around the whole battery pack for the structural integrity. And therefore, it was a comprehensive design challenge as well for the team. And now the primary focus of designing the battery pack by ourselves was to maximize the energy capacity that we have for the car, and also to put as much power as we can in a really small package. That means we save a lot of weight by saving a lot of power. And therefore, to ensure this, that the battery runs efficiently, we also need some kind of monitoring device to make sure that the batteries we are using, they are always in optimal shape. And therefore, we decided to also design BMS by ourselves. As you can see on the slide, those BMS boards are designed by our team, and we have assembled it in-house by ourselves, also written software for it. And the primary function of the BMS, as we all know, that's a battery management system to make sure each and every cell inside the battery pack is at its optimal level. So we prevent cells going into overcharge situations, over temperature, or over discharge. And that is really critical for the battery life, because we will be running the car throughout 3,000 kilometers, and that means a lot of charge and discharge cycles in the batteries. And also, given the case of continuous operation of the battery, the temperature in the outback is also one of the challenges that we have to conquer, using a good thermal management, which we can gather the data from the BMS. And now, as we've also seen, that we have our driving strategy team, and to make a decisive action, we need certain data. And here we can precisely measure voltage of each and every cells and temperature that we can provide it to the driving strategy team, which can efficiently calculate the optimal strategy for us. And now, we have laid our foundation of the energy storage. But what do we do with that? The main primary thing is batteries are itself a powerhouse, but we need to regulate it. And therefore, we also have designed a battery DC-DC board, and that basically handles the power conversion for the battery itself. So it regulates the power inflow inside the battery and outside the battery. That means at all the time, we have control over the power, how much power we give to the car. Because as we know, the challenge is of solar-powered car. And therefore, that means we need to use as much solar energy that is available for us. And the battery DC-DC ensures that we use the battery at its optimal level, and therefore leveraging the solar power for the best performance. And now to describe the furthermore parts, Shoradip Singh will take over.
Thank you, Janish. This on? This on? Is it on? Is it here? Amazing. Hello. Thank God. So thank you, Janish, for the wonderful insight for the first energy storage system. Is there any alumni from LE that built a prototype? Just for an insight, this is not the first solar car that we have built. I will let you guys find out afterwards which the first one was. But yeah, so let's get to what we're doing something for the first time. This of size has never been in our workspace before. It's only been here for a few weeks now. But it's a new challenge that we have never seen before. That is a second energy storage system. Now, as Janish has already mentioned, we have the battery pack. Theoretically, we could drive and power the entire car just using these solar panels because they're just so big. And the battery can act as a buffer, which is really what we want to achieve, because we want to save our battery and maximize the power from these cells. And that is why we developed our own MPPT DC-DC, which basically converts the energy from the solar modules and maximizes the efficiency, which is very critical over a varying range of voltages. Because obviously the sun doesn't shine from the top always. It's moving around, and due to the greenhouse, there's always a bit of shading on all of these cells. And these modules are designed in a way with using bypass diodes, so we can efficiently use all three modules all the time. which is why designing this DC-DC converter for the MPPTs for a highly efficient cycle over all voltage ranges and during all times of the day is incredibly crucial. Which is why also, thanks to Tom and a bachelor thesis, we were able to lay the foundation at Professor Helwein's chair, who is not here today, regarding our entire electric system. So I just want to say thank you to him. He's not here, but yeah. Now, how do we really do this is we basically simulated the energy from the solar cells over the course of the 5 days that we'll be driving, because now we will be driving in winter and not in October, which is usually more sunnier than August is. That is why it's really crucial to simulate these 5 days using the weather data from the Australian government, basically, over the last 10 years to see how the energy cycle of these cells will be. And with this help and using really highly efficient GaN FETs for these low voltage ranges, we are able to build a really efficient DC-DC, which is not something most teams do. They just buy them. So I'm really proud that we are doing this. Incredible achievement. And yeah, so the next part of our car. Yes, so now we already spoke about two energy sources, the solar modules and the battery cells. Now, this thing takes almost 95% of the entire power that we have, which is kind of crazy. And that's why it's really so important. What we see here now is the second version that was designed by our team, where we designed the first version last year to see how we could participate at this challenge with such a high power inverter that we were not doing before. And this way, we were also using GaN FETs and really amazing components from all of our sponsors. Thank you. We were able to design a really highly efficient inverter that can challenge what other teams have built themselves. And also our control systems teams who are also here. Thanks a lot who are working tirelessly for improving our motor control software and testing various software algorithms throughout the season that we are able to select what's best for us and what runs best with our motor, because just the motor itself can be really efficient, but what drives it is the inverter, and it has to be efficient together with the motor. And now, after all of this high voltage power stuff, let's go on to lights and LEDs. That's kind of very simple to explain. Yes, so we have, according to our rules, this car has to drive on the Australian Autobahn, basically. So we need to fulfill so many requirements, so many tiny things that we never knew about. And we also had a conversation with one of our sponsors here about that. We just, that this is in so much detail, all of these things are done, that every component has to be selected precisely just to make sure that we qualify for all of these rules. And the thing that runs these components in our car, basically the rear lights, the front lights, the horns, is this board, basically. It's called a telemetry board. We used to call it the Wonder Board last year, the main control unit. It had many names, and now we just call it the telemetry board. It's responsible for all the driver functions, including the display, the rear view visual camera, and the dashboard buttons, which the driver controls. Additionally to that, we have integrated numerous sensors into our car to, obviously, that helps the running gear team. That also helps the driving strategy team, such as the IMU unit and the RF module, which is basically a very crucial point in our car that is used to help communicate with the chase car that's driving just behind the solar car during the race. This helps the driving strategy team. Obviously, they will be working overnight in Australia once they get all of the data, once we have driven for one day. And hopefully, all of the data that we assemble helps them a lot to develop their strategy. And yeah, this is all from our electronics. We also have the steering wheel controller, obviously, that you can come here and see later on. And I just want to say thank you to all of our sponsors who have supported this season. Obviously, everyone has mentioned this so many times. We are really, really grateful for every one of you. All of the components you have provided us in time. This is a really intense project. No one is doing all of these things that we are doing, and we are doing it for the first time. So maybe we are stupid, I don't know. But it's really, really important that we do this. And so we can also push the boundaries of efficiency in our systems. And I also want to thank all of my teammates who have worked tirelessly. And yeah, there's more work to do. Thank you.
Okay, that was very well said, Shuri. So yeah, no, this car really has been our baby over the last 2 years, and I mean, I don't want to keep thanking everyone. I just, like, everyone has already said it. I thank the team, I thank the sponsors. We are so immensely grateful for your support. You have given us the platform to bring this project to life, so really, thank you. Now, if you want to know how, like, if you have any questions about everything that was said before, I invite you to, in this next part, come and talk to us. You can recognize us by, well, the black polos that we're all wearing with the blue TUfast logo on it. Very important, blue. But yeah, if you have not gotten bored of us yet, then there's some more drinks and there's dessert in this next part. Oh, I do have one more thing to say that I am obligated to say. I'm responsible for the marketing here at TUfast Eco Team, and so I invite every single one of you to give us a follow on Instagram, TikTok, LinkedIn, and YouTube, please. If you want to see how our journey continues, how this really beautiful car drives in Australia, just check out our page and we'll be posting regular updates. So yeah, after this, you can come forward, you can take a closer look at looks. Just one thing, please, please, please do not touch the solar panels. They are very fragile and they are very expensive. And yeah, we don't want them to break. So yeah, but feel free to come forward, take a closer look, take pictures, take videos, tag us if you post anything, and yeah, this would be all from my side. I see two people who are very eager to come on stage and say some last words. But yeah, thank you for coming tonight. Thank you for making this evening really unforgettable for every single one of us. And yeah, let's keep this going. Thank you.
Yeah, so hello again. As Malou already said, and as everyone has said, we also want to give our thanks to everyone here. This project was only possible because we have so many supporters. May that be the TUM, may that be our sponsors. We couldn't have done it without every single one of you. I want to give out an especially big thanks to our main sponsor, Audi. And also to the TUM Universitätsstiftung and the TÜV Stiftung, who helped us a lot in the past months. And now, the last big thanks is definitely to our wonderful team. Every single one of you helped make this happen. Late nights, long weekends. I know it was hard, but I'm really, really proud of what we achieved, and I just want to say thanks so much. Yeah, without you, it wouldn't be possible.
I hope this works. Ah, it does. Okay, I guess 3 is the charm. I also want to give my thanks again and again and again because I think it is necessary and this is quite important. You all guys, I'm speaking directly to the team, all of you, without your effort, without your hundreds of hours spent in this project, this car wouldn't be here. It wouldn't look as beautiful as it is, no matter what part you did. It doesn't matter how big or how small it is. Your effort was needed, your effort was unbelievably important. You made my last 2 years, or more than 2 years, very special. It is incredible to be able and to be allowed to be your technical director. I need to be honest, it's really amazing. It's very special, and you do an amazing job. Keep up with that. we're going to reach something very, very great in Australia. I know that. So, yeah, thank you so much. And now I would certainly invite the whole TUfast Eco Team on the stage, because we want to do team pictures. So please, 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 all of you come up here so all of the guests can see you and we can do a team picture together. Thank you.